A warm welcome to Nandal. I'm Yogeshwari, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi, College of Arts and Science, Autonomous Coimbatore. Now I am taking to uh, the discrete structure and optimization techniques. The topic is assignment problem. So the Hungarian method is computational optimization technique that address the assignment problem in polynomial time and foreshadows the following primal dual alternatives in 1955. Harold Kuhn used the term Hungarian method to honor to Hungarian mathematicians Dennis Koning and Geno Egerway. Let's go through the steps of the Hungarian method with the help of the solved example. Hungarian method to solve assignment problem. The Hungarian method is a simple way to solve assignment problem. Let us first discuss the assignment problem before moving on to learning the Hungarian method. What is an assignment problem? We know that and already I teach you in what is assignment problem in the above topic. The transportation problem is a type of assignment problem. The goal is allocate an equal amount of resource to the same number of activities. As a result, the overall cost of allocation is minimized or the total profit is maximized because available resources such as workers, machines and other resources have varying degree of efficiency for executing different activities and hence the cost, profit or loss of conducting such activities varies. Assume we have an n job to do on m machines. Our goal is to assign jobs to machines for the least amount of money possible. So based on the notation that each machine can accomplish each task but at variable levels of efficiency. Hungarian method steps. First one, step 1. In the given cost matrix, subtract the least cost elements of each row from all the entries that row. Make sure that each row has at least one zero. Step 2. The in the resultant cost matrix produced in steps 1, subtract the least cost element in each column from all the components in that column, ensuring that each column contains at least one zero. Step 3. Assign zeros. Analyze the rows one by one until you find a row with previous one unmarked zero. Encircle this lonely unmarked zero as assign it to a task. All the zeros in the column of the circular zero should be crossed out because they will not be used in any future assignment. Continue as this manner until you have gone through all the rows. Examine the columns one by one until you find one with previously one unmarked zero. Encircle this single unmarked zero and cross any other zeros in its row to make an assignment to it. Continue until you have gone through all of the columns. Step 4. Perform the optimal test. The present assignment is optimal if each row and column has exactly one encircled zero. The present assignment is not optimal if at least one row or one column is missing on assignment. Continue to step 5. Subtract the least cost element from all the entries in each column of the final cost matrix created in step 1 and ensure that the each column has at least one zero. Step 5. Draw the least number of straight lines to cover all of the zeros as follows. Highlight the rows that are assigned. Label the columns with zeros in mark. Label the columns with zeros in marked rows. Highlight the rows that have assignment in indicated columns. Continue with B and C until no further making is needed. Simply draw the lines through all rows and columns that are not marked. If the number of these lines equals the order of matrix, then the solution is optimal, otherwise it is not. Step 6. Find the lowest cost factor that is not covered by the straight lines. Subtract this least cost component from all the uncovered elements and add it to all the elements that are at the intersection of these straight lines, but leave the rest of the elements alone. Step 7. Continue with step 1 to 6 until you have found the highest suitable assignment. For an example, use the Hungarian method to solve the given assignment problem stated in the table. The entries in the matrix represent each man's processing time in hours. So we have five teams and five jobs and 5 minutes. He started problem is balanced, so A is equal to some matrix. Then subtract the lowest cost in each row from all the elements in the given cost matrix row. Make sure that each row has at least one zero, and subtract the least cost element in each column from all the components in the given cost matrix column. Check to see if each column has at least one zero. When the zeros are assigned, when we get the following matrix. So here first row we have 1 0, and second row we have the 3 0, so skip now, and third row is only 1 0, fourth row we have 2 zeros, skip now, fifth row is only 1 0. Then the row wise as a zero allocation is finished. So next going to column allocation. So first column already we know assign the 0, so leave now. Cross out the remaining 0, and third row, second row is only 1 0 already allocated. Third row only already 1 0 is allocated, so remaining 0 is cross out. Fourth row only 1 0, so we want to allocate now. Then fifth row is already 1 0 is allocated, so fourth row fourth column only 1 0 is allocated, so second column have 0, so remaining 2 zeros are cross out. Then fourth column only 1 0 is there, so we want to allocate now. So next one, the present assignment is optimal because each row and column contain previously one encircled 0. So when we want to allocate the job to the job to the person 1 to First work is to first second man, second work is fourth man, third work is first man, fourth work is fifth man, and fifth to all, and five to third. Okay, um, are the best assignments. Hence, we want to add to the values. So z is equal to 86 hours. So the total optimal time is 86 hours. Thank you.